All right, good afternoon, ladies and gentlemen, and welcome to Fighting for a Five, episode 15, where we will go over the document, problem number 16. Of course, brought to you by Couch Potato Brand Snack Foods and Beverages. Thanks once again to Kevin and Sean for creating this absolutely breathtaking logo. Of course, I'm your host, Mr. Giratina. And today we are going over this problem that deals with a group of 9 people, 3 of which are going to be randomly selected to go on to attend a national convention. All right, so we have this group of 9 people, 6 men, 3 women, 3 people randomly selected. What's the probability that from this group we randomly select all 3 women? All right, so we are looking for the probability of 3 women out of 3. Now, this almost sounds similar to a binomial random variable where we're counting the number of successes in a certain number of trials, where in this case, selecting a woman would be a success. But this is not exactly a binomial random variable, and I'm going to pause for a minute to give you some time to think about why not. So think now. All right, so hopefully you have thought about it. The reason why we can't model this situation using a binomial random variable is because there's such a small population that we're drawing from that each selection is not independent, right? So since we don't have independent selections, we cannot model this situation using a binomial random variable. Anyway, that being said, it's actually fairly straightforward to get 3 women out of 3. So for the first selection, the probability of getting a woman would be 3 out of 9. But once you've selected that woman, you have to make sure to take that woman out of the population. So now there are only 8 people left in the population, 2 of which are women. And then finally, once you've selected 2 women, there are only 7 people left in the population, 1 of which is a woman. So you have a 3 out of 9 probability times 2 out of 9 times 1 out of 7. Now, the thing that we need to focus on, hold on one moment. Okay, I'm back. One thing I wanted to mention is that since in this situation we are looking for 3 women out of 3, it's actually pretty simple because there's only one way that can happen. If you look at the tree diagram of like all the possible outcomes, there's only one way that this could happen. But in the future, like if on the AP they ask for, oh, what about 2 out of 3 of the choices are women, we would need to take into account all of the possible ways that could happen. For example, if 2 out of the 3 people selected were women, it might have been the first 2 were women and then the last one was a man, or we could have woman, man, woman, or we could have man, woman, woman. And I think those would be the only 3 ways, but we would need to take all 3 of those ways into account when we're calculating that other probability. All right. But again, for this one, there's only one way that it could occur. And so this is the only combination or the only product that we have to worry about. Of course, your final answer should be expressed as either a simplified fraction or a decimal to 4 decimal places. Okay, part B. Based on your answer to part A, is there a reason to doubt the manager's claim that the 3 people were selected at random? So actually, I am going to convert this to a decimal because it'll give me a better sense of what's going on. Give me one moment. All right, so it turns out that the probability that you obtain 3 out of 3 women is 0.0119. or approximately that number. So I'm going to now use that information to decide if I am doubting the manager's claim that they actually chose a random sample. By the way, the key phrase here is based on your answer to part A. Now, I know that it's kind of obvious in this case. Like it would be hard to answer this question without using the information in part A, but just for future reference, if a question asks you to base your answer on a prior bit of information that you solved for, please be sure to use that prior bit of information explicitly. All right, so, all right. If this were a random selection, then there's about a 1% chance of obtaining this outcome. I don't know about you, but that seems kind of rare. So I might say, if the selection were random, then you would obtain 3 women about 1.19% of the time. This seems too unlikely, in my opinion, and I would doubt the manager's claim. Okay. Now, the interesting thing is, and I saw this discussion come up in the question stream, well, what if you think that a 1% chance is something that's feasible? I mean, after all, it does occur 1 out of 100 times. That's far from impossible, right? And the answer is you're more than welcome to say that you think, since this is a feasible outcome, that you don't doubt the manager's claim. You're more than welcome to say that, as long as you word it in such a way that you believe that 1% is a feasible, realistic outcome, right? Now, you might recognize that. So another thing that came up in the stream was, in the question stream was, what's the cutoff between something that's too rare versus something that's not very rare? And that's an interesting question. And hopefully you're drawing a connection between this and what we use the alpha value for, right? In a hypothesis test, that's exactly the role that the alpha value plays. It decides for us when we should reject H null. In other words, when we should decide that this is too rare of an outcome to believe the hypothesis or the premise, or when we should fail to reject H null, when our outcome does not seem that rare and where we can't really reject the premise or the null hypothesis. All right. So in this type of situation, when we're not running a hypothesis test, you don't necessarily need to state an alpha value, but the rule of thumb is like anything below 5% is considered rare. Again, that's an opinion thing. So you're more than welcome to state that you don't doubt the manager's claim. Just make sure that your wording is clear, that you think that 1% is a realistic situation. Alrighty, part C. Now the manager says, well, I don't know if the manager is saying this, but the question goes on to say, an alternative to calculating the exact probability is to conduct a simulation to estimate the probability. All right, so that's typically what simulations are for. In very complicated situations, when probabilities are difficult to calculate, we would run a simulation to get a sense in the long run, what's the probability of certain events. Not that this is a complicated situation, so I'm not sure why you might do this, but anyway, they did have to ask a part C. So this is their proposed simulation. Each trial in the simulation consists of rolling 3 fair 6-sided dice, 1 die for each convention each of the convention attendees. For each die, rolling 1, 2, 3, or 4 represents selecting a man, and a 5 or 6 represents selecting a woman. Now, this kind of makes sense, right? Because 4 out of the 6 faces represent man, and 2 out of the 6 faces represents a woman. This makes sense because in the population, there are, 6 men and 3 women. In other words, 2/3 are men, 1/3 are women. So far, so good. Okay. Now we're going to take 3 dice and roll all 3, and we're going to pay attention to what each lands on. And so once again, each will land on a number, and that number will represent either a man or a woman. The question is, does this proposed process correctly simulate the random selection of 3 women from a group of 9 people? Explain why or why not. Now, hopefully you understand that each die roll is independent of the other die, or I should say dice. So each die roll is independent of the other dice. However, in this population, and I'm going to actually say in this small population, each selection is dependent on previous selections. In other words, what I mean here is that whenever I roll a die, the probability of the first one coming up woman is 1/3. The probability of the second one coming up woman is 1/3, and the probability of the third one coming up woman is 1/3. But that doesn't really match the probability that we calculated, right? Here, this 3/9 represents the probability of selecting a woman first. Yeah, that's 1/3. But then, of course, since this is a small population, we do have to adjust the probability of selecting the second woman after the fact that we've selected the first woman. And so the probability of selecting the second woman, given that we've already selected one woman, is now 2/8, and it is not 1/4, and it is not 1/3, so on and so forth. So therefore, since realistically we have dependent selections, this dice simulation does not work. So I will go on to say, therefore, the dice roll simulation does not properly model the true situation of selecting 3 women. Just that the last few words of selecting 3 women, I'm just trying to add some context to the problem, which of course is always a good idea. I'm reading over my answer and I forgot to write the word in this small population. Each selection is dependent on previous selections. Therefore, the dice roll simulation does not properly model the true situation of selecting 3 women. Yeah, so there you go. Let's just go ahead and check out the scoring guidelines. So this is their sample answer to part C. It says, no, the process does not correctly simulate the random selection of 3 women from a group of 9 people, of whom 6 are men and 3 are women. The random selection of 3 people among 9 is done without replacement. However, in this simulation, the dice, the 3 dice rolls in any given trial are independent of one another. Okay, great. So obviously you do not have to write what they wrote verbatim, but let's see what they would give you essentially correct for. Wow, that's a lot. I'm gonna pause, read through it, and if there's anything that I think is worth mentioning, I will bring it up. So let me pause it. I'll be right back. Yeah, so basically, as long as you mention something along the lines of the dice being independent and the actual selections being dependent, then you would get full credit. Of course, please, 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 please make sure to include some sort of context. Rereading my answer, I only have this little bit of context that relates it directly to the situation. That's probably pretty bad on my part. I would like it if you maybe just try to incorporate a little bit more context. Each selection of, like I could say, each selection of person is dependent on previous selections. Just any sort of like little sprinkling of context will only help your case. All right, ladies and gentlemen, that is all for today. Sorry for the delay, and hope you are enjoying your Thursday. Take care. Bye.